My name is Palma Gonzalez and I am the Industrial Fuel Switching Program Manager for Glass Futures. This program is funded by BASE and is a £7.1 million project. We have a different range of partners, including members from industry, the supply chain, and also academia. And the project is looking into a different range of biofuels, hydrogen, electric melt, and hybrid fuels. The approach into this program is to look into 4 different aspects to the fuels. So the technical aspects, the economics, health and safety, and of course environmental, in order to help the glass sector to achieve the net zero goal target by the government by 2050. The program comprises of a series of tests. We've got pilot scale tests, we have done hydrogen glass melting studies, oxygen and hydrogen trials, and we've got a 350 combustion test bed where we are investigating natural gas, hydrogen, biofuels, and blends of these fuels. In the program, we're also doing some industrial trials, such as the one we did with NSERC, Container Glass Company, and we are planning to do another trial with NSG in February 2022 for flat glass. Today we are at Glass Futures facility where we have got the 350 kilowatt furnace, and we are going to have a tour around the rig. So the combustion air is directed into the preheater where the air is warmed up to 1000 degrees, and this is done by means of a series of passages where the air circulates through, and in the passages we've got silicon carbide elements that warm the air up to the desired temperature. The air then goes into the combustion test bed, which essentially is a U-shaped furnace where the air and the fuel go in on one side, make a U-shaped flame, and then go out through the other side. The fuels that we've got are put through 2 burners, and they are underport burners. In the CTP, we haven't got any products, but the thermal load of whatever we want to simulate is done by a series of water-cooled pins which simulate the thermal load that we want. The waste gas and the combustion products are then extracted through the flue, and they go into an ejector, which is a venturi essentially, where the contraction creates a low pressure, which then sucks the air and the gas into the pipe, and we've got air dilution to cool down the gas before it goes out into atmosphere. For the fuels, we've got a gasket which has got 4 different lines. So we've got a nitrogen line to purge the system, we've got an LPG line which we are not currently using, we've got natural gas, and at the top of the gasket we've got hydrogen. So the oil skids, we have got 2 different lines which we can use separately, and the tanks are 1000 litre tanks, and they've got the capacity of preheat the fuel in order to be able to pump it into the CTB through the burners. The oil burners have got Atomizing Air, and the aim of the Atomizing Air is to break down the fuel input into very small drops in order to enhance the combustion of the fuel. The project will run for 6 weeks, and we have already baselined the furnace on natural gas, and we are baselining now on red diesel. Then we will move on to the biofuels to be able to compare the performance of the natural gas and the red diesel. I am confident Glass Futures will find a route to decarbonize glass and foundation industry manufacturing. The combustion test bed is currently located in Rotherham at one of Liberty Steel's sites, but it will be moved to our pilot plant in St Helens once all the projects we've got in place are over. One of the main advantages of the rig is that it offers a complete flexibility to suit to whatever demands are required, such as we can modify the back wall to modify the air inlet conditions. We can also modify combustion conditions as well as the thermal load that is extracted through the water-cooled pins. If you are interested in using our combustion test bed, please get in touch with Glass Futures.